Welcome everyone at this time's Aerial Robotics Community Working Group meeting. It's October 11th. 8th actually. October 8th. My mistake. It's actually a presentation meeting, so that means that one of us is actually going to give a presentation about a certain topic that they've introduced. So first of all, of course, I'm going to start with a couple of announcements that are important within the aerial robotics community. Then we're going to have a presentation by Ramón about the PixHawk. Then I'm going to announce the topic for the next meeting and the conclusions and everything. So it's all going to be exactly the same as the previous meetings. So some announcements. I don't know if anybody of you have been monitoring the Discord channel, which is the hashtag CWG-Aerial on the Open Robotics Foundation Discord. They have already started quite a bit with a lot of development. So if you're interested in that, you probably can take a look. And also the PX4 Summit talks are now online on YouTube. So here's the link. So if you have missed it, like I did, check them out. I will. And also a small announcement as well is that some of the people that already joined this meeting already noticed there's a UAV simulation review paper out that I'm a co-author of. It's called The Survey of Simulators for Aerial Robotics. And great credit to all the co-authors that have been helping out, especially Cora and Giuseppe. We submitted it to Robotics and Automation Letters, but it's already available on the archive right here. I will just share the link later in the chat below. But first of all, I would like to give the word to Ramón. He's going to talk about PixHawk. So go for it. You can share your slides if you want to.
All right. Thank you everyone for joining us today. Time zone differences aside, I'm glad that we all could make it today. Let me just get my presenter view going. Oops. Chrome tab. Here we go. Please let me know if you can see this or this aspect ratio okay.
Looks so good to me. Go for it.
All right. Well, first of all, for those of you that missed ROSCon, I had a talk. Well, me and Kim had a talk on day 2. We introduced the work group and we presented all the discussions and work that we've been doing for the last few months. So thank you everyone that participated through the year that helped us make that happen. I don't know that ROSCon talks are live yet, but there's a stream too live already in their, I think, Vimeo page. So you can find that and you can see the 40-minute talk, by the way. Was not easy, but Kim pushed through. Thank you, Kim, for doing all of that work. Hopefully next year we can do it together. All right, so today I'm here to talk to you about PixHawk. I know that a lot of you have stumbled upon PixHawks upon your careers and have wondered how this is all put together. So I wanted to give you a quick introduction to where this project is coming from and what are the goals behind it, but most importantly, how is it that we transition from open hardware to open standards, and how does that affect the community, and how does it affect you, and how do you can take advantage of all the PixHawk hardware that is out there. And at the end, I'm going to give you a few words about what's happening in the future. All right, so without any more intro, because I'm going to spoil my talk. Here we go. So if you don't know me, I'm the general manager for Drone Code Foundation. Just a quick link so you can find me: GitHub, Twitter, well, X, previously known as Twitter, and my email. I work for the Linux Foundation, and yeah, that's basically a good intro. So who here doesn't know about Drone Code? Basically what we do is we're a nonprofit that we host open technologies projects for the drone industry, PX4 Autopilot, PixHawk. I'm going to give you a quick slide with all of those projects. But most importantly, there's companies that are sponsoring us with yearly memberships that are helping us fund all of these efforts. I wouldn't be here without them. So huge thanks to all of them. All right, so this is what we really are. We're the home of the PX4 PixHawk ecosystem. So what does that mean? So we have projects on one side, like Q Ground Control, MapWing, Map SDK, but we also have standards. MapLink is also a standard. I don't know if you knew that. There's outside of our bubble with Drone Code, people are using MapLink because there's a quick benefit to adopting a messaging protocol that is defined as a de facto standard in the industry. PixHawk is also a standard. There's also third-party projects like ROS. This is the reason we're here. And then the industry association could be Linux Foundation, Ground Code, which is sort of surrounding all of this and encompassing it so that companies can feel trust in participating and collaborating. So it's really important that all of those things together are in one piece under one roof. All right, so these are our top-level projects. This is what we're here to talk about. And if you want me to introduce any of the other projects at a different date, I'll be glad to do that. But today we're going to be focusing on this right here. So PixHawk open source hardware and open standards. But before I jump into that, and I'm going to give you a quick slide on what PX4 is, just in case if you don't know, because it's going to be crazy if I talk about the hardware and if I don't tell you what it actually does. First, quick sip of coffee because it's my first coffee of the day. All right, so we like to say the Linux kernel of drones, although it's not really a kernel. It's an analogy that we do for business people so that they understand where does this live. And actually kind of works because Trunk of Linux Foundation analogy. So it's just a way to illustrate it, but no, by no means this is an OS or a Linux kernel one-to-one match. All right, so what it actually is a module that runs, or an app that runs on top of an RTOS called Nutix. All right, so for those of you that don't know what Nutix is, it's a real-time operating system that runs on embedded devices. Most importantly, on STM32s, F4s, H7s, and G series, and all different ones. But now we're also running on RISC-V and on NXP-based microcontrollers, not just STM. So for the future, I'm going to give you a quick talk towards the end of like what's happening on the future for hardware. But for now, running on an RTOS means you have a quick scheduler that allows you to precisely mandate control over devices. I'm trying to not go too much in depth in here, but what we have, it's a collection of apps, modules in the RTOS that we call PX4. Although there are many apps within PX4, but that might be confusing if we presented it that way. But we have different modules that interact with each other with a middleware. Sounds familiar, right? It's actually a UARP, it's a PubSub, and it acts similarly as to DDS. So it's actually DDS compatible. It's one of the reasons why we have a DDS interface, because the modules within RTOS is already using this PubSub. So we have an estimator module, we have a navigator module, we have all kinds of modules that are talking to each other and have different messages that are coming back and forth. Now, one of the benefits of PX4 is that we have a parameter system that we expose to the users. So users are able to configure runtime configure certain aspects of PX4 so that they can actually fine-tune it or adapt it to whatever needs they have. One of those things that you could do is you can say, oh, the DDS interface, I don't want this on this port. I don't want this to be connected to this IP. So you change those things. Now, we also have a MapLink interface. This MapLink interface is basically what we use to hook up to ground stations. And what pilots typically do is have their ground station connected to the flight controller and share telemetry back and forth. Now, that telemetry is through MapLink and not through the PubSub, the UARP, because typically up until now, which more modern drones do, we've had radio telemetries that are lossless, so you couldn't really do real-time communication before. Now, with more modern topologies and network architectures, you do have more advanced Wi-Fi based mesh radio networks, so that you actually are able to use DDS over the network more consistently. But enough of that. I can talk to you about that if you're interested later. One important aspect, if we do support not just multicopters, we do rovers, land-based. Not so well, though, as multicopters. We also support boats. We also support underwater vehicles. And we support very good VTOL. We have really good support for big swing, really good support for multicopters. Any configuration of multicopters. If you go to our documentation, docs.px4.io, you will be able to find all the different vehicles and how to configure all of those. All right. So having all of that firmware, how do we actually consistently run that on hardware in a way that is safe? And what do I mean by safe? All right, so the industry is in a state where drones are tools now. So you need really dependable hardware that runs this firmware. So you need to have a guarantee almost that when you're choosing your hardware, you're not going to have to spend thousands of hours on engineering time to make sure that your firmware and your hardware run well. So introducing PixHawk. So PixHawk is a drone. It's a project that is dedicated to advance the drone industry. What do I mean by that? All right, so at the beginning of time, and I'm going to give you more slides on that, but just the beginning of time, it was meant as a low-cost flight controller, because back when this was created, which was around 2009, 2010-ish, Dr. Lawrence Mayer, the author, was working in his master's, and he wanted to do computer vision. So there was nothing out there. And he created this hardware standard or open hardware project, which was actually not really meant to be as successful as it was. It was just a tool that he needed, a piece of hardware he needed to be able to get his computer vision master's finished. But little did he know, we're estimating that we have more than 1 million devices out there. So it's a pretty successful project. And it kind of evolved from an open hardware project into an open standards, and I'm going to give you the reasons why. And everything is published on GitHub right now, and it's sort of like the base, the hardware, the brains of the operation on drones. So if you've never seen a PixHawk before, this is a PixHawk. This is a picture here is a PixHawk 4, one of the most famous. And actually, that unit right there used to cost $200-ish. Now, if you want to buy a PixHawk 4, the original ones, it's probably going to be $800 up to $1,000 because it's so reliable and it's so widely used, and it's no longer produced, so it went up in price. Before I go on, I just want to mention that this isn't just something that Drone Code did. That we don't manufacture anything. And these are some of our manufacturing partners. All of them listed there have either a PixHawk variant, deviated from PixHawk at some point, or actually help us continue push for PixHawk. So we have dozens of flight controllers already out there. It's not just one like I pictured before. All right, so again, this guy. So this guy created PX4 in PixHawk just so he could make his master thesis. So he was working in ETH Zurich, and this is the actual first PixHawk, the PXIMU. This is what he used to be able to do that. So there's actually a really famous post on DIY drones where he introduced the firmware, or the project. So, and I love this quote, and I constantly use it in my slides. So if you've seen this before, I apologize, but I would love to say this. So please note that PixHawk is currently evolving from a research system to an open source community platform. It's kind of like the understatement of the industry. This was in 2010. So after publishing everything, he made this happen, and we had very wide success across the industry. So this was the first one. You might have stumbled upon some of these before. So the 3DR PixHawk, which is the other original one, the one that actually made all this happen, which have the HK Pilot, the 3DR PixHawk Mini, the Pix Falcon, the TroPix, the Embro 2.1, the Embro PixHawk, the Cube, the first Cube, the black one, the CUAV PixHawk. Oh, and notice that this is PixHack, not PixHawk. Drawtex PixHawk 3 Pro, the PixHawk 4, the PixHawk 4 Mini, CUAV B5, B5 Plus, CUAV Nano, a lot of them. And I didn't even put all of them, just the ones that I kind of was able to secure pictures for. But all right, how did we go from an open hardware project to an open standards? You gotta understand that we have everything at GitHub, like schematics, every piece of details that you need to be able to manufacture is in GitHub all to FMUB5. That's PixHawk 4. So if you go to GitHub/GitHub, which is the org, you will find everything in there. Like, I'm not joking. Everything is there, and it's version, so you'll be able to download everything. So don't believe me. Go to GitHub right now, and you'll see it for yourself. All right, so we started with very open-minded philosophy, and it helped us massively. Like, we gained a lot of adoption, as you could see, but it also brought a lot and I mean a lot of unintended consequences. Because we really didn't really think this through. And back then, there weren't really many, let's say, projects that did it successfully, that went from just a research project to open hardware and from a community in a way that actually allowed us to see, oh, we're gonna go this way like they did. There were very few. And we were young and naive to believe that we could sustain the industry this way. So let me tell you why I mean that. So in our beginnings, the financing of everything happened within the PixHawk team. That means the manufacturers didn't really spend money doing this. All right, let me rephrase that. Manufacturers did pay for manufacturing. I'm not saying they didn't, but the PixHawk team actually made the design from scratch, and then we helped manufacturers implement it. But we didn't really charge them anything. All right, this task required a team of 2 to 3 people in any given time. And we help with everything. We help with validating the hardware designs. We tried to keep them as close as possible to the reference design that we made. So if you notice, each generation has one big manufacturer. So let's say the PixHawk 4, we have Polybro. So we worked with them to manufacture and design the first one. But then everything else that was BFM UV5 came and used that reference design to try to mimic that. But we couldn't just share those schematics openly with everyone. And we couldn't continue to do that in the future. So because, I'm kind of jumping ahead here, but we worked with the manufacturer. We helped them put it together. We helped them port the firmware. And then we helped maintain the firmware build targets. So this, as you can imagine, has a high cost of maintenance for the PixHawk and the PX4 teams. I'm kind of getting excited by this, so I'm getting my brain's jumping ahead. So I'm gonna take it slowly. All right. So what are the things that actually worked from an open hardware perspective for the project, and what are the things that did not work at all? All right. So let's start with the positive. We gained massive adoption, like massive understanding. Again, if you go and ask anyone in the industry, PixHawk is the thing they're using. Now we form an ecosystem because there's many manufacturers that are building PixHawks. So it is not just one single project, not one single vendor. You have tons of volume and options for people. So if you want to buy a PixHawk, let's say few years now, like 5 years ago, you had options. Like I just showed you a bunch of hardware. So we gained the trust of manufacturers because we were helping them build things that the community wanted. So like we were in good standing with everyone because we were providing them with hardware. But it's the same thing that happens with software. What are the cons? All right, well, turned out that even if we give them the source files, hey, here's everything, manufacturers still thought that they had to change design. Now, it could be for any amount of reasons. Maybe because they wanted to differentiate, then that's a very valid reason. Or maybe because they wanted to do some cost savings on the side and change a few sensors. And it was rarely for the better that they changed it. What I mean by that is that most often than not, when a change was introduced downstream by the car manufacturer, they actually didn't tell us. So the firmware that we gave them, and sorry, I just realized I didn't tell you. So PixHawk is meant to work with PX4. So the PX4 team is supporting this. So the promise for manufacturers is that if you adopt PixHawk, you don't need to worry about the firmware because we take care of that. That's why it's important to follow the reference design. But it turns out that manufacturers changed the reference design for X amount of reasons, but they didn't tell us. So the firmware stopped working, but they didn't really realize. So they sold you hardware and you started trying to test it and you didn't realize, hey, this sensor is not working. And then later we realized, oh, it's because they changed the sensor, but oh, it's fine. We have a driver. But then we realized, oh, but it's a different rotation from what it was before, but now we have to change the firmware. Those things ended up hurting us a lot because where did the people came for support? when that happened, not to the manufacturers, they came to PX4. So some manufacturers will work with you if you have an open hardware project, but most will just download, make the changes. And what I mean by apprentice manufacturer, of course, but then start selling without actually validation. So users started losing credibility in the project when things didn't work. And there was no financial incentive for the authors and no sustainability plans for the project. So that means that PixHawk was not in a good shape. It was sort of kept on going because we believed in the project. So entering the new era, and I promise that I'm gonna give you more reasonings than this to why we did this. So one of the options that was discussed is, hey, why don't we just take this project and make it closed? Why don't we just sell this to manufacturers and work with them? And that's a way to just actually have quality hardware. But that was against everything that we believed in. So we decided to go in the midway between open and closed. So we sort of decided that we were going to do open standards. And we tried to capture the basics of what the hardware is. And this is only for flight controllers, by the way. We still do have other types of open hardware, which I'm going to show you later. So if you go to the PixHawk standards repo on GitHub, you'll see that there's a lot of PDFs that describe all the open standards, especially for FMU V6X, which is the latest flight controller. You'll see that we have a very comprehensive documentation and list of everything that's in there. There's a pinout in there. So if you really wanted to build a PixHawk, you can just go there and sort of work your way backwards from the pinout to actually make the hardware design. Now, if you know a bit about hardware, that means that you still have to spend a lot of time to actually design that. It's not easy. All right, but what else are we doing? So Throncode is in charge of maintaining the standards. No longer just 1 or 2, 3 people that is on the side as a PixHawk team. And then we use foundation resources so that we can keep everything up to date. And we also started offering some sort of validation. And then we formed the PixHawk Special Interest Group, and Throncode is helping with maintaining all of this. We focus the work groups, and then we create support, and we safeguard the PixHawk trademark. What does that mean? All right, well, how does this actually work? We fixed some problems. We actually created a bit more, and there's a lot of impact to the community. And I have another slide, and hopefully I don't spoil it. So what are the things that actually are working with the open standards? So access to the core project is still open. We have finer control over who has access to the source files. We share the maintenance burden of the firmware of the hardware and the hardware. And then to participate, and you need to be part of the foundation. And then at the beginning, I told you how Throncode is supported by members. So the membership costs are actually offsetting the cost of the project. So now that means that we have a sustainability project plan for this project. And then we started offering validation and conformity plans so that we can help manufacturers. So we don't just give you the schematics. We can also provide value by helping you make sure that, hey, we validated that your design is actually up to spec, because we now have the pinout that we have to adhere to. But what is it that didn't actually work? And this is probably something that is on your mind while I'm speaking. So the pinout will give you direction, but you still have to walk the path. There's a lot of engineering hours that you need to spend. You need a membership to actually access the source file of the schematics, and that's a paywall. And then while you participate in public meetings, because all of our meetings are public, because you're probably seen on social media with our calendars and all of that, only members have voting rights over the final decisions. And that's really important. And then initially, only a few hardware options will be available, because only a few companies will have the schematics. So those companies will have a very short amount of time. Oh, sorry for that noise. We'll have a short amount of time from design to actually start selling. And they'll have a few months ahead or years from anyone else that is trying to work backwards from the pinouts. All right, so this is bound to have a lot of impact in the community. So before we actually made the decision to switch, we made sure to talk to all of the key stakeholders and partners. We talked to all of the manufacturers that had been built not just our partners, but also to the manufacturers that we were building clones before. We reached out to everyone, all of the PX4 devs. We reached to members of our community, so the end users, everyone that's been using PixHawk. We tried to talk to everyone. And so we're sorry we didn't have a chance to talk to you. We really went out of our way because we were really concerned about trust in the project and the credibility, because changing a project like this requires a ton of effort and requires the community support. So what did we learn by all those conversations? Well, turns out that the end users, like the users like you and I, were impacted the most by unreliable hardware with no quality control from specific manufacturers, mostly clone hardware. To this day, you can still go to Alibaba or some huge retailer online that sells hardware, and you'll just type PixHawk, and you'll see tons of different options that are really cheap. And you have to sort of question, where is that coming from? And what is the actual design that they're actually using to do that? Because a lot of those sensors that are on the original design are no longer available. A lot of those chips are no longer available. And then thanks to the pandemic and the manufacturing crisis, supply chain issues, a lot of the sensors are no longer available. So what are they actually using and replacing them with? Certainly, they have never sent the pull request to the PX4 repository to actually update drivers or update board design. So please be careful when you go out there and try to purchase PixHawk hardware. Make sure it's from a trusted manufacturer. What else did we find? Manufacturers require hand-holding to implement the designs. It's not enough to give them the source files. What we thought was a very good process of us working with one manufacturer and handling the design and just going through the whole cycle. We thought it was a really clear process, but it turned out it didn't. Manufacturers were very uncomfortable doing this because it was a top-down direction. So PixHawk team decided everything, and then we tell you what to do. And manufacturers didn't like that. They wanted to sort of have their voices heard because they were the ones that were actually in the battlefront. And that's okay. Battlefront is not a good word. They were working with the end user and their customers, so they were getting the feedback. So they were the ones that actually experienced this firsthand, and they had a lot of feedback to give us, and that didn't always came through. So the last one, it was one of the most important ones. The PS4 team was on the receiving end of all the complaints from the community, because when things didn't work, you go to where the firmware is and you assume it's the firmware. So if to this day, if you go to our GitHub, you'll find a lot of issues of, hey, my hardware doesn't work. It's a FMUV2 from a really old generation. And that's one of the reasons why it doesn't work. So let's talk about the good impact. The solution that we did is that we formed a special interest group with some of the manufacturers and maintainers of PixHawk projects, that everything under drone code. We put together recurring coordination calls. So you can still join our meetings. It's bi-weekly on Thursdays. Anyone can join. Anyone can share their opinions. We're happy to work with everyone. To this day, there's not really a lot of conflict resolution, because like most of the decisions have been made. But let's say we wanted to make a new generation of PixHawk designs, and X company wants to really do it this way, and then this other company that is not a member wants to do in a different direction. We have a way to deconflict that. It's only members only voting. Why? Because there's the ones that are actually helping us financially support the project. And memberships are not really that expensive. If they start at $5,000. And for manufacturers that are actually selling PixHawk, that's basically a day of sales or less for them. So the group that watches over the creation and maintenance or validation of the open standards is the PixHawk Special Interest Group. And DroneCode and the members are footing the bill for everything. So what actually did we achieve by doing this? And this happened over the course of like the last few years. We gained 200 increase in participation in the development of new open standards. So we went from a 2 to 3 person team to having companies with 2 to 3 engineers each helping us design and create this. Like, let me say that again. We went from ourselves doing everything to recruiting companies that have a vested interest in actually supporting us. If you've been working in open technologies, open source long enough, you'll know that this isn't really easy to achieve, especially not by changing sort of like the license, even though we didn't change the license. We tried and really hard to incorporate them, and we sort of achieved that. Now, the only time we'll say if this was successful or not, we'll see. We increased the sense of ownership for all the parties involved, and we have a clear neutral path for the funding of the project. So this is what the SIG is. These are some of the members. We have more, and I apologize if your logo is not here. This is always a problem when I'm doing slide for logos. But what is it that we actually do in the SIG? So we have a few different work groups, which right now we're not currently developing a lot of new hardware because, like I said, we have this generation that is out there and sort of like supporting a state right now. We have the FMU, which is the flight management unit for the flight controllers. We also have payload work groups for gimbals. We have BMS for batteries, and we have radio interface, which is really fun way now that a lot of companies sell tablets with ground stations. But what happens with that tablet doesn't work with the new hardware you have, new generation, because they changed the radio. So there's a module interface that you can replace that is supposed to be a standard way to change the radio on the ground station and also on the vehicle. So all of that is also defined. And we have different standards. Like I said, if you go to PixHawk/PixHawk standards, you'll be able to download all of the PDFs and all of the information. Some of these standards, like the payload standards, even have mechanical designs that are provided by companies. So you sort of can take the schematics for the mechanical design, and you can implement that. Some don't, only have the pinout. So this is how the latest generation looks. This is the Altair Skynote, and this is Hollywood PixHawk. Again, just a quick note, there's way many options right now. This is just so that you can picture in your mind right now. This is what FMUB6X is. And the sensor set, the list names of sensors here are based on the first revision. So they're not what you might find in any given hardware, and I'm going to tell you why. So at the core, what's most important is that we have a STM32H7 base design. We have a secure authentication module by NXP. It's a secure element. So if you wanted to take advantage of that secure element, you could actually configure this so that it's tamper resistant, tamper proof. We have Ethernet, which is something that we never had before, and it's sort of what is allowing a more advanced ROS and PX4 integration thanks to the DDS middleware. And we have 3 redundancy domains that is actually what makes us and sets us apart. So we have completely isolated sensor domains with separate buses and separate power control. And we allow for parallel and continuous operation, even in the event of hardware failure. So all the sensor sets that you have here, what we've done, if you go to the FMUB6X document, which I think is the drone standard DS /0014 or something like that, you'll see that if you scroll all the way to the bottom, there's up to like 7 different revisions of sensor sets. And each one of those is from different manufacturers. What happens and what would turn out is that thanks to the manufacturing crisis, supply chain issues, a lot of those sensors were no longer available. And then over time, they might get deprecated too. So we started offering options to the manufacturers to actually differentiate by choosing what sensors they want to implement. And we are sort of resilient on the firmware side to actually be able to help them with that. Now, a second thing that we introduced in the latest generation is the modular design. So we have sort of like the baseboard on this side, which has this connector standard. And it's a standard that I actually forgot to mention here is the PixHawk autopilot bus, which is the actual connector that you see on the carrier port. That is an open standard. So that you can actually go and look at. If you wanted to, let's say, build carrier boards or build a drone that has like an OEM drone, that has the PCB, and all you care for is the FMU that you're going to secure for someone else, you can do that. There's actually companies that are Drunk Good members right now that don't sell flight controllers, but are actually implementing the PixHawk autopilot bus because that allows them to just procure the FMGU modules from someone else, and they worry about the rest of the system. And then the actual FMGU module, you have the FMGU-M and then the IMU on top. Those are actually modular as well. There's companies that are actually selling just the IMU on top from different sensor sets in there. All right, enough of this. Quickly jump into the payload standards. PixHawk payload standards. This is for gimbals, and I'm running out of time, so I'm going to try to go quickly, and I'm almost done. The payload interface for gimbals has Ethernet, has USB, has ConfFD, UART, trigger, capture, GNS, VCC. What does this mean, and what is this actually? Well, this is how it looks. What happens is that if you've been in drones long enough, you'll realize that if you purchase a gimbal, most likely it won't work with every vehicle. Or if let's say you have a company that you trust, like whatever, I don't want to name anyone, I don't want to pick on anyone because I get in trouble by doing this. If you purchase company name X, a gimbal, you won't be able to use it with company Y because they sort of like are different concept, different companies. But now what is going to happen, and it's when it's actually already happening, is that if you purchase from company X and they actually support the gimbal payload standard, you'll have options to purchase gimbals from gimbal manufacturers that are actually adopting the gimbal standard. So you won't be locked to a single vendor. And as a developer, what this means, if you look at the specs or the interfaces here, and by the way, the firmware side of this is on MapLink. There's a MapLink component to this, which allows you to take advantage of this interface and have 360 integration. What that means is plug and play from the mechanical standpoint, and then from the electrical standpoint too, and then the firmware thanks to MapLink, you'll have integration all the way to the ground station. So not just the flight controller, it goes all the way to the ground station thanks to MapLink. Battery standard. This is something that is not yet completed, but we're working on trying to standardize this. The main blocker here is battery connectors are, I don't want to say hard, but just it's a very delicate component of a drone because vendors tend to want to lock in the different connector. So that's why we've been struggling to try to get this to completed state. But this is how one of the batteries of the BMS standard looks like, which that's one of the connectors on the front. And the promise here is that you will be able to use CAN to be able to manage your smart battery system. If you go to the DSO13 document, you'll be able to find way more info on this. Quick example, and I don't know if this is going to play or not. This is the FreeFly Astro. This is actually implementing Skynote flight controller, the battery BMS system, and the PixHawk payload interface. So all of our standards are there. And it's allowing this company to actually be able to very rapidly work with this vehicle and adapt changes to whatever they need to. All right. If you're interested in more of that, please go to their website, FreeFly Systems, and just look for the Astro. All right, so this is the end of my talk. If you're interested in building PixHawks, this is how you can get involved. First, the best and easiest way, like I already said, is by getting a membership, a Drunk Good membership, and you'll get access to schematics, save you a lot of time, and will help you sustain your project. You'll help us in return to actually fund everything that we've been doing right up to this point and whatever is going to happen in the future. But if you really want more, because like I said, getting access to the schematics is not just enough anymore. We are offering a standards validation, a very, very cost-efficient fee of $2,500. $2,500. And what this gives you is that if you have looked at the PixHawk ecosystem, we have tons of different carrier boards and different FMGU modules. We'll actually test your FMGU module and your carrier board against other vendors that have already participated in the validation efforts, and will guarantee that you'll be plug and play compatible. So what that means is you take flight controller for this company and plug it into a different company, and it'll just work. We also offer PixHawk design services. Also, flat fee will help you. Let's say you have an idea in mind, you want to change the sensor set, you want to change a few things, provided you don't change the mechanicals, we'll help you with that. It's also a flat fee. And then we'll also have access to the PixHawk trademark. As you've seen, not every flight controller that is based on the PixHawk standards is actually called PixHawk, and there's a reason for that, because we have never really allowed a lot of companies to get access to this. Now that's changing. We're going to allow different brands to use the PixHawk trademark for a flat fee of $5,000. And there's some requirements, like, for example, and most importantly, no dual use hardware, so no dual intent, no defense applications that are using this as PixHawk branded. And most importantly, the second most important thing is that you need to pass validation in order to be able to call this a PixHawk, and then obviously pay the fee. Now, there's a lot of money involved here, and turns out this is a very expensive project to run, so we're trying to just recover some of the cost. Up until this point, one of our biggest backers has been Alparian, which they actually helped make the design. They helped make most of the PX4 firmware porting and supporting. And we're trying to make sure that drone code is sustainable in a way that we don't really just rely on one big company. Although we really love them, we really are grateful for their support. We really want to make this a very big ecosystem, and there's a lot of companies that are already jumping on board to actually allow us to do that. So stay tuned. We'll see a lot of different hardware coming up soon. All right, any questions?
All right. Thanks a lot, Ramon, for this great presentation. I would say that from my understanding now, also like a lot of the things that you have, the reasoning why you have gone to open standards instead of open hardware is now much more clear to me, of course. Like open hardware, everybody's like, oh, kumbaya, everybody joins, but that's not how reality works, right?
Yep.
I just want to add, like, at least from Bitcrate's point of view, like we had like the same exact issue with the Crazy Fly 1. We completely open hardware that, and that's very much backfired in that sense. So the Crazy Fly 2 is now kind of like more of an hybrid open hardware, let's say, only schematics, none of the boom, but like, so I definitely understand a part of that here. So we have a couple of questions already, so let's try to go as quickly as we can, because I think you only have 5 minutes.
All right. Yeah, please do raise your hands on. That really helps us. So right now, the only raised hand I see is Ryan. So Ryan, please go ahead.
Yeah, I was just curious from a payload perspective, if there's any plans to have any standards for how payloads do live video to a companion computer, or is that outside of the realm of standardization for drone code?
Yeah, it's a tricky question because, well, it's a tricky problem, not a tricky question. So the MapLink interface does mandate a few things on, like, I think where the URL for the stream is, I think, but it doesn't really tell you how to achieve that stream. And I think that's a big area of opportunity. With any standards movement, there's a lot of companies doing it differently, and everyone thinks they're doing it the right way. So we definitely need to standardize that. And now, thanks to a bigger focus on the companion computer, I think we're in a good time to actually do that. So standardizing that would be definitely a priority. We don't mandate it right now, but we should definitely do that.
Cool, thanks.
Yep.
All right, I think, Andrew, you also had your hands up if you're online and present. It seems that you have maybe some issues with your internet. Andrew?
Oh, no, sorry. I was looking for the applaud button and just hit the wrong one.
Okay. Yeah, no worries. Okay, so like if nobody else have a question, I perhaps have a question. Myself, I as you know, I come from the academic community, and I kind of know what sometimes, like, they usually have like a Frankenstein of all kinds of things to make their own drones there, and they probably don't have the funds to, or maybe the time to really join and have the development and kind of hack things together. Usually a lot of papers kind of revolve around a new sensor that they kind of want to have their own drivers for, but they're probably are not really able to open source it yet until the paper has been published. Like in that sense, like how would they approach something like that if they cannot really, like, they would like to have support for a new sensor, but it cannot really be in the open yet. Like, how would they, if they would need to go through like the right pathways, let's say through like the open standards at Drone Code Foundation.
So they want to have a variant of PixHawk with different sensors, but just they don't want to publish it yet. That's the question. How do you do that?
Exactly. Like for instance, they've made a new, let's say, event-based camera or something like that, but they don't want other people to use it yet because their paper hasn't been published yet.
Yeah, I run into this really a lot of times, and I don't think there's a really clear answer to that, other than that, don't publish it because once you do, like it's out. And that's actually, and I'm gonna deviate from your question a little bit, but if you don't really have reason other than I just want to share, it's gonna become really hard to sustain the open hardware at some point. And let's say you're gonna be locked into having it all out and open, because once you put that out there, you cannot take it back. And I've seen companies try to emulate what PixHawk has been doing by just releasing schematics and everything. And then when another company picks them up and starts manufacturing that, then they get like, whoa, why did you do that? Why are you copying this? And it's an unintended consequence of doing this because they just want to belong and participate. And it's a very valid way to do it. But they sort of miss the point that, yeah, it's out there and anyone can just take it and go with this and take advantage of all the resources and time you spent already doing this. So be careful what you put out there. And this is like, and I feel crazy because I'm the open source guy, and telling people not to open source things just because they want to open source it is, guys, kind of goes backwards against what I believe in. But I also believe that if you're going to put something out there, you got to make sure that you're ready to support it, because people are going to be using it. And if you don't really have plans for that, then just don't do it. And I sort of like didn't really answer your question.
No, yeah, I guess it's a very difficult question. I think the academic community hasn't really figured that one out yet. So I think it's good for now. I'll just like to give the word to Andrew. Is that a hands up, or is that a or was that an applaud again?
Sort of a comment question for Ramon in relation to that. There's one exception that you didn't mention, NXP, and the fact that I believe they're publishing the diagrams for their new one, for their new FMU they're working on. I know they published the ones for their previous one, but that's because they sell the processor. So if a manufacturer uses it, they still win.
Yeah, well, actually, I'm working with them on that one. So that's going to be part of announced at the PX for Dev Summit. It's the PixHawk FMU B6X RT, which is based on NXP microcontrollers. And they won't be openly publishing their schematics, but they will be sharing them with whatever manufacturer needs them to actually be able to implement that. Yes. Oh, okay. And that's and that is actually a very valid use case. When you actually want to gain adoption fast, and you have the means to support that adoption and volume growth, then that's when you do it. Then that's actually a great comment. Thank you, Andrew.
All right. I think we have to kind of like divert questions to like perhaps an email to you, Ramon, because it's 5 minutes to 5, and you would need to probably go as well for the community Q&A of PX4. So I'm just going to go ahead and share my slides to kind of give the final words.
Yep. And then everyone, if you have questions, I'll be in Discord too. So if you can find me there always.
Oh yeah, of course. Yes. Yeah. So I think that will be a yeah, so I realized before that I said 11th of October. Of course, that's completely wrong. I'm dyslexic, by the way. It's an actual condition. So as you noticed all, yeah, so the thing, it's the November 8th meeting. And of course, Ramon, a lot of thanks for the great presentation. Already thank you before. The topics, this is kind of the list of topics that we kind of handled already. But there's only a few left, and I think probably like the planning in 3D is the most important, as you said, that the 3D planning rogue group of ragtag 3D planners have already started their major developments. So I think it will be very good to talk about 3D planning for the next meeting. So no poll this time. I've also kind of like put this the upcoming meeting in GitHub projects. I don't know. I like the overview to kind of show you what's kind of the meetings that we still have left over. So so that's kind of like a nice timeline. So we have the 3D planning discussion. After that, I think also we're going to have a presentation about autopilots and ROS by Ryan. I think that will be in that will be in December. And then the last meeting of the aerial ROS working group meeting is probably going to be like status so far, kind of an open discussion of what we would like to do in the new year of forming groups and everything. So I just want to kind of let you know what's up ahead. So developer discussion meeting about 3D planning, which is going to be Wednesday, 22nd of November, 3 p.m. UTC. I'm going to make sure that it's going to be changed in the Google Calendar so that Ramon doesn't have to wake up as early as 6 p.m. That is just ridiculous. So yeah, let's see if the time bug won't hit us again, but it probably will. So the GitHub organization from the working group is github.com ROS Aerial Robotics Landscape. So and also add yourself as a member if you want to do a presentation in the new year in January. Of course, there's plenty of opportunities still left, so just send me an email or Ramon an email, or contact us on Discord, of course. Yeah, so that's it. Ramon, thanks again. I would like to see everybody in 2 weeks again. Thanks for joining.
Thanks. Bye-bye.
Thanks.
Bye-bye.
Thank you.